Hi, welcome to Azure User Group Sweden. Hi, Håkan. Good noon. Good Saturday
Yes.
noon. We are live today.
Good midday.
Midday. How is the weather like in Oslo today?
Actually, right now it's snowing, so I guess it's a couple
Oh,
of degrees cold and a little bit gloomy. So it's a good
yes.
day to stay inside and look or listen to our session, I guess.
Yes, that's right. I mean, I also have a cloudy day right now where I am mid North Sweden. So no sun, but it was out. It was also cold, but it's good to be back in our first episode. Actually, in 2025, we have been busy since the holidays, so it's good to kick off the event or meetup again virtually with a new topic, which is today will be about how we can navigate container hosting on Microsoft Azure with a speaker that has been with us for the previous episodes. I look forward to that. But before we start, let me just say hi to everybody that's watching us live and even recorded, and also introduce Hokan, my co-leader. So we're gonna introduce each other just to be inclusive to those that it's first time for them. So Håkan Silvernagel here is my co-community leader of Azure User Group Sweden. He is also a fellow Microsoft MVP focused on Azure AI technologies. He works as a senior AI architect at Sopra Steria in Norway, and also very active as an international speaker, an MCT, and also in the .NET community in Oslo and AI community in Oslo, specifically the AI 42 and Oslo AI. And yeah, so glad to have Håkan as my continued partner in community events for this user group, because without the leaders, there won't be a user group. So thank you, Håkan.
Thank you for a nice introduction, Jonas. I'm also very happy and proud to be able to present the founder of our community, Jonah Anderson. She is a Microsoft MVP and also a Microsoft certified trainer and the Microsoft certified trainer community lead. She is also an international speaker and an author of the book Learning Microsoft Azure on O'Reilly. And she is also a podcast host and Microsoft Learn expert. And in her daily time, she works as a senior Azure consultant at Solidify.
Yes, that's awesome presentation. Thank you, Håkan. So before we start and bring in our special guest today, our friend also in the community, let me just share to everybody about our code of conduct. So, as a community and also part of Azure Tech Groups, we have a code of conduct where we are expecting everyone, including ourselves, to be nice and friendly, listen with purpose and be thoughtful, be respectful to others, don't criticize, be curious and open to share your ideas on chat or during the interaction within the session, and be inclusive with your questions and comments with each other. And if you think that there is a room for improvement for our code of conduct, or somewhat you feel violated, feel free to reach out to me and Hokan on LinkedIn. And also, we will be having a fika, like it's our tradition where at the end of our live stream, you are welcome voluntarily to join us to have a 15-minute or 20-minute discussion about the topic that we have today, along with me and Håkan and our guest speaker sharing it. So in this session, you get more like private conversations about what you want to discuss. So scan the QR code or use the Bitly link later at the end of the stream, which we will be recalling also later on. All right. Did we have more, Håkan, before we bring uh, our guest,
No,
John Kilmister, on stage?
I think that's pretty much it there. So we are
Yes.
very happy here to welcome our speaker, John Kilmister.
Hi.
Welcome, John.
Hi.
Hi,
Welcome
thanks for having me
back.
back.
So John has been with us before, but I would still like to give him a formal introduction here for those who haven't seen him before. So Kilmister is a Microsoft MVP for Azure, and he's also a Principal Software Architect and a software engineer that enjoys exploring new technologies to solve real-world problems. He has a background at e-commerce companies, and he works as a Principal Software Architect, working with teams on both web and mobile applications.
Yeah.
So we were happy here to have you back. What will you be presenting today, John?
Great. Yeah. So I'm going to be talking about containers and container hosting more precisely. So I've worked with lots of different teams trying to run containerized applications in the cloud. And it's not always obvious. In Azure, there are 6 or 7 different ways of hosting a container. So really what we're going to do is just go through all those different options at quite a high level, just so that people are aware of why you might use one over the other, and inspire people just to have a little deeper look at some of them that they might not have heard of before.
Okay, that's interesting. That's amazing. I look forward to learn more from you, John. And to our live audience right now, watching us from different channels, YouTube and LinkedIn, or X. I think we're also streaming there. Feel free to pose your questions or comment on the live chat, and John will answer the questions at the end of the session. So yeah. And yeah, let's bring the presentation to stage, and the stage is yours, John.
Great, thank you. So as we said, the topic today is container hosting on Azure. It's quite a high level talk. We're not going to be able to go through the entirety of, say, Kubernetes or anything like that, but we'll go through the pros and cons of each of the hosting options and why they might be suitable for different use cases. We've already kind of done the introduction of me, but I have been a software engineer for now 20 plus years, and more recently focusing on Azure and the Azure platform. You can find me on socials at John Kilmister on Blue Sky, X, and various other places. And I do have my blog at blueboxes.co.uk where I talk about this kind of thing. So why containers? Well, containers are a really great way of hosting your software. And a lot of people are, in fact, using them. In a recent report in the Docker 2024 State of Application Development, in fact, it's 80% of developers are using them in some part of their development process. Now, that might be as simple as hosting a container with a database in, so you can do local development. It might be something like test containers, where you're spinning up containers on a CI/CD process in order to run integration tests against. Or you might go all the way and use something like dev containers to have your whole development environment running inside an isolated container. So we have really good adoption on the development side of things. But when it comes to actually putting these into production, things look slightly different. And in a second report that was released last year, we see that only 47% of people plan to use these in production. So already we have a discrepancy. We've got 80% using it in development, but only 47 plan to use it at some point in production. And even more surprising than this, only 12% have done so already. So we've got a huge discrepancy. People obviously like containers because 80% are apparently using them in a development environment. Yet when we actually get through to production, we're rarely hosting them. So why is that, and how can we overcome that? Well, when you start talking about putting containers into production, we start thinking about some of the things you don't have to worry about in development. So things like scalability, disaster recovery, networking, how all the containers are going to talk to each other. And very quickly, the conversation turns to technologies that are already out there. And the word Kubernetes comes up really quickly. And Kubernetes is a great platform. And it is a huge a huge ecosystem of tools and technologies that can help you host your containers. But if you're new to the space and you want to put your Docker container, your application into a production environment, you start reading around Kubernetes, then you start realizing that actually it's not that straightforward, and it can be really off-putting. And there are stories of companies that have moved to Kubernetes only to move back again afterwards, because it is an entire ecosystem. The way I look at it, it's much akin to moving between, say, the Azure cloud and AWS. Everything's pretty much there, but it all has a slightly different name and works in a slightly different way. So even if we're using Kubernetes on Azure, we've got a whole load of new terminology to understand, and also a whole load of new ways of working. So that's really the point of this, this presentation. When we talk about hosting containers, especially in Azure, we've got to remember that Kubernetes is an option, but as with many things, when it comes to software development and engineering, it's not the only option. So we're going to be taking a look at all of the different options and seeing which one may be suited to different use cases. Now, before we talk too much about hosting our containers, I did want to take a little bit of a step back. I realized that not everyone is a software developer and engineer, and you might be an operations person just taking container images and wanting to host them in production. So before we go any further, I want to do a little bit of a recap on our containerization workflow, and then we can see which bits we're going to be focusing on today. Well, all software that wants to run inside a container starts life as a Docker file, a set of instructions on what base image we want to use, and then any additional software that we want to copy into it, including any custom software that we may have built. And that Docker file is a recipe for how we want our image to be built, our container image to be built. And that is the next stage. We have to go through a building process. And once we have that, we have a Docker image. Now, typically, we would then take that image and push it up into a registry. Now, a registry would be something like Docker Hub or Azure Container Registry. And this is sometimes where people start from. If you're using a public image that's already been built for you, you might go to Docker Hub and just consume that image. But there would have been a Docker file and a build process at some point in the past. If you're building your own files, your own images with your own custom software in, obviously then you create your Docker file and build the image and then push it up to your artifact store. Once it's in that artifact store, that's where our journey for today really begins. And it's often that we don't want to just run a single container. We'll often want to run multiple containers side by side, or at least networked together in some way. We'd also want to add in some storage and various other components. So we have orchestration definition. Now, if we're in the world of Kubernetes, that's something like a Helm chart. If we're in some of the other environments, we might be looking at something like, say, a compose file. And then once we have that, we can then actually run our container, taking the images and the orchestration, and we can run that. And as I've alluded to, there are many different ways we can run that, and that's our focus really for the rest of this talk. Now, when we look at Azure, when we look at all of the different containerization options, they fit on a scale of serverless all the way through to infrastructure as a service. And this is much like any other service in Azure. Most services on Azure will fit somewhere along this line. So what are our containerization options? Well, we have Azure Container Registry tasks. You might not think of these as a hosting option, and I guess typically it's not a hosting option, but it is a way that we can run container images in the cloud. That's completely serverless. We have Azure Container Instances, a service that's been around for a really long time. It's quite basic in what it does, but it is cheap and does a good job. We have app service plans. And app service plans have been in Azure since 2012, 2013, something like that. And they now support containers. We have Azure Container Apps, a relatively new service compared to the others. And it functions a lot like app service plans, yet is backed by Kubernetes. So you get the best of both worlds. You get the ease of use from app service plans, but you get the richness of features that you get from Kubernetes. Then we have Microsoft's hosted version of Kubernetes, Azure Kubernetes Service. There are other options though as well. Certain PaaS solutions such as Azure Functions or Databricks allow you to run containers as part of that PaaS solution. We have container workloads on Azure Batch, and we can also still stick with containers on virtual machines. Now we'll go through each of these in a lot more detail, show you how to spin them up and look at the pros and cons of each and the use cases. But I wanted to just put them all here on this line of serverless all the way through to IaaS, just to give you an idea about why some of them exist. And when we compare serverless, PaaS and IaaS, what we're really talking about is that with a serverless offering, you're going to get less complexity. That means we can get started quicker. And it also means there's going to be less maintenance. You're not having to patch servers, design networking, and things like that. However, there are some trade-offs. And the first one is that for per hour of compute, typically serverless will be a higher cost than infrastructure as a service. That said, we can't just take it at the price of the compute, because where you have a more complex system that's going to take you longer to get going and higher maintenance, there are costs associated with that, in addition to the pure compute costs that you've got from Azure. Equally, on the serverless side, although per hour the compute may be slightly higher in some cases, you might be able to run them down to zero, so scale to zero. So there are times when it's not costing you anything. So the cost element of it is a really interesting one, but at a very high level, serverless will generally cost you a bit more inside Azure because it is doing things like maintenance for you. The other trade-off that we have is that you get less control with serverless. When you're in a PaaS or an IaaS solution, you get more control, you can tweak more things, but obviously that comes at the cost of more complexity. Now, what I show you here is true for any sort of serverless PaaS IaaS solution, not just around containerization. So when we look at these, we're going to actually be looking at the services in a slightly different way. First of all, we're going to talk about the key terms, because each of them have different terminology for what is essentially the same thing. We'll also look at the structure of them. Some of the options require some prerequisites before we get started, and the compute is located at different levels. Most importantly, we'll look at the different features for each one. And finally, we'll look at the pricing model, which will help us understand what might be best for each scenario. So getting started with our first one, Azure Container Registry Tasks. As I say, it's not a true hosting option, but it is a way of running containers and has some really useful features. We do our configuration all through the Azure CLI or basic YAML. Because it's not a true hosting solution, we don't have any GPU support, no attached storage, sidecars, init containers, and there's no real way of scaling them as such. But we can spin up containers under both Linux and Windows, which is not something that's available with all of the options. So why would we use them? What are the advantages? Well, these have pretty much zero setup, and we can run containers as either a one-off task, a multi-step task, or we can actually trigger them based on various activities. As I mentioned, there is no real scaling option. However, we can have dedicated agent pools, which these tasks will run on, which give you a bit more flexibility about scale and size. Note that is under Linux only, and it is preview. So when would we want to use this? Well, we can use these for CI/CD processes, and we can use them for, say, automatically triggering scheduled maintenance tasks. So if you have a container image that's just going to go through and tidy up some files, for example, we could schedule that to run under Azure Container Registry tasks. These are billed per second of the task running, so you're only charged for the actual duration of that task. I do have a blog post which covers Azure Container Registry in a lot more detail, because it's not just an image store for OCI images. It can do an awful lot more, including running these kind of tasks. But I want to show you a bit more how this works and put it into a bit more context. So one of the unique things about this way of running a container is that the image actually has to be in the Azure Container Registry. This is not true for any of the other options I show you. You can actually pull your image from any registry. But for this one, it has to be in the Azure Container Registry. And we do that by pulling down our image locally, tagging it with our Azure Container Registry URL, and then pushing it up into that registry. Once it's there, we can actually execute it by running this one simple command, ACR run, passing in the name of the registry, and then passing in both the image name and the command. When we run that, and we'll just run that quickly in a command line, what you'll see is the terminal output from that once it starts running. Before that, we can just see the job is queued, pulls down the images, the different layers of the image, and then you can see it ran, and it ran successfully in 8 seconds. You can't run these directly from the Azure portal, but you can set up the schedules on the command line and view them in the portal later. So this is the container registry in the Azure portal, and if we go down on the left-hand side to tasks, and then we go to runs, we can see the previous runs, and if we click into any of those, you see pretty much the same output. So let's now move on to our first true way of hosting our container image, Azure Container Instances. These have been in Azure for a long time, and as such have quite a rich feature set. Also, some other Azure services use these behind the scenes. So the way they work is we set up an Azure Container Group, and that Azure Container Group is the compute. So we specify how much memory and CPU we want for that entire group. You can then put into the Azure Container Group one or more containers. Now, the configuration for this is done via YAML or Bicep. There is support for GPU, however, it's not recommended. If you want GPU support, it's recommended that you use Kubernetes now. We can use attached storage if we're using Linux containers, and it kind of supports sidecars by the fact that you can have multiple containers in the same compute. But a key thing here is that there is no scaling at all. If we want to change how much memory and CPU, we have to re-provision the group, and if we want to change the number of instances, that's not possible. They also run on Windows and Linux. So why would we use these? Well, the main advantage is that they are a very feature-rich service. So we have things like private service endpoints, private link, VNets. We can get a public fixed IP address for them. And if any of the containers fail, they will just restart. But the main limitations are, as mentioned, that it's not possible to scale once deployed. And there's no easy way to put an SSL connection on it. So if we want to host a website through ACI, it's a bit of a challenge. There is a way of doing it, but it's fiddly, and these are not really suited to that. So what are they suited to? Well, they're suited to running one-off background tasks that don't need to scale and don't need any persistence. I personally have been using them for Azure DevOps build agents. So the build agent takes a job, it executes it, it then shuts down the container. Then what will happen is that the automatic restart kicks in, it comes back, and we have another agent completely fresh, ready to take on new jobs. However, using Azure DevOps build agents in this way, they don't auto scale. So you have a fixed number of agents, unlike if we had a VM scale set or something like that back in those agents. But it is a useful use case. And we're charged for the CPU per second and the gigabytes of memory per second. So let's have a look at how we create these. All of the examples that I'm going to show you going forward will be using the AZ CLI. Now, that's just because it is really easy to see what's going on here. We can condense it all down into a few lines. But you can create all of these different resources in the typical ways. So using Terraform or Bicep, using the PowerShell commands, using the AZ commands like we are here, and in many cases also through the Azure portal. So we're just kind of using the AZ command line just to make it easier to see what's going on. So in order to create your container group, we use the AZ container create, and we can pass in the resource group and name, but also the image name. And this image then will get pulled down from that repository. We specify our OS type, our CPU, and memory. We can also, if we want to expose any ports, put them on that as well. Once that's deployed, we can see it quite clearly in the portal. You can see that there's a container instances, and we can see we've just got a single container. On the right-hand side, you can see the restart count 14 because it will just keep restarting it unless you specify for it not to be. We can see the properties, so we can see how many CPU cores and memory that we have, and if you've got any GPUs, that's there as well. We can also see the environment variables. Now, if we want to change any of these, we do have to redeploy. From the logs, we get to see the output, very similar to what we did on the container registry tasks, and you can see what's going on. And you can also connect into the container if you need to debug it or have a look at the underlying system. So how would we run multiple containers in this way? Well, we can use a YAML file, specifying that in this way. So instead of passing in all the details, we just pass in a deploy.yaml, and then we can specify underneath in a separate YAML file the images and the ports and various other bits. So we'll move now on to specialist images. These are, it's not an official term. I just wanted to group together and really highlight a few services. So there are some services in Azure which are PaaS, where you don't have to worry about the underlying infrastructure at all, or serverless, where again, we don't need to worry about that underlying infrastructure. But rather than moving completely to containers, we can actually use containers to enhance the service. So things like machine learning. With machine learning, you can pass a model that has, pass a container that has a model in it into that PaaS service to use it. Or with Azure functions, we can actually run those on containers, but without having to worry too much about all of the other bits that we need to provision. So yeah, the main advantage of using these are that we have seamless integration with existing Azure services, but you are bound by the limits of that service. So they're only going to expose certain bits of customization. It's a great way of customizing PaaS services without moving your whole application to containers. And with the pricing model, these are different dependent on the service that you're looking at, but do have a look at the docs for more details. Now, app service plans. I really like app service plans. I've been using them for many years, well, pretty much from when I started using Azure back in 2015. And if you haven't used them before, It gives you the ability to upload website code, say a zip file of your web application, and it will then run it for you. There are really easy to use scaling options where you can just slide to have more instances of it, and all of the underlying management of the system is done for you. Well, they now support containers. We can take our application, put it into a container, and get the app service to run it for you. App service plans work by provisioning a single piece of compute and then placing your apps inside it. And that can be a web application, Azure function, or web jobs. Now, that's also true for when we're putting containers onto our app service plans. The little caveat is that web jobs are still in preview for Linux app service plans, but the mechanism is the same. We provision one piece of compute, and then we put all our containers into that. Now, by only having one piece of compute, that means that when we scale it, either vertically or horizontally, we are scaling all of the web apps on that compute. So if you've put lots of different websites all on the same app service plan and you scale it up, it's then going to scale all of those together. We configure this in pretty much the same way as any other piece of Azure infrastructure, so primarily through Bicep or Terraform, although you can do it also through the portal. There's no GPU support at all, and the attached storage and sidecars are all in preview. But we do have the option of running these containers either under Linux or Windows. Now, the advantage of using this is that this PaaS solution already comes with loads of great features out of the box. So you get free managed SSL certificates. You also get various networking options. We have deployment slots and easy auth. We can also have webhooks for auto deployments, which I'll cover a little bit in a minute. There are some drawbacks though. So containers running on app service plans is a feature that was added to them a little while back, but it was an addition to an existing platform. And this means that we're missing some of the things that you might get under a Kubernetes service, such as full health endpoints. So in an app service plan, we can only specify one health endpoint. Under Kubernetes, we actually get to specify a number so that we not only can check if the application is alive, but also if it's ready to accept requests. Under app service plans, all the containers are also public by default. And we don't have support for things like Dapper. And as I've mentioned, scaling is also done altogether. This means that they're not great for hosting microservices. If you have a number of backend APIs plus a number of websites and you put them all into one app service plan, then they will all scale together, which might not be suited for what you're wanting. A key difference is they also can't scale to zero. So even if you stop every application in that app service plan, you are still paying for the compute. So when would we use them? Well, they're still great for public websites where we need to auto scale while minimizing the infrastructure management. I found them really good to be a stepping stone. So if you've got apps on an app service plan today, you could switch over to using containers on an app service plan with very little change to your infrastructure before potentially moving on to other compute options for your containers. The pricing model for these is that we do need to select a plan that is a set of CPU, RAM, and storage, and that is then charged per hour. You can get started from free. There's also a basic, premium, and isolated compute plans if you need to. So let's have a quick look at how we go and create these. Again, using the Azure CLI, but we can use other methods. We create our app service plan. This is our compute, at which point we're specifying if it's Linux or Windows, and we're specifying the SKU. Now, we've also then got to put our apps into it because that's just the compute. So we create the web app. Now, if you've done things like zip deploys, this is where you'd specify the name of your zip to upload. But as we're doing container images today, you can see there we can specify the container image name. Now, your container might not be working on the default ports. So traffic coming into the app service plan will be coming in on port 80 or 443 if it's secure. And if we want to route that through to, say, port 5000 on the container, then we can do that by setting one of the environment variables, website ports to 5000, for example, in this case, and then that will route it all through successfully. A lot of the customizations that we can do to how the containers work under App Service Plan are done through environment variables. Now, if we want to deploy a whole group of containers at once, we can do that through a compose file. This is in preview, but it is available. So we just specify that it is a multi-container deployment, and there is a compose file. Once we've done that, we can actually see our app service plan in the portal, and under the deployment center, we can see the details here. So we can see, in this case, we have a config, which is the compose file, but equally, we could have just picked an individual container image, either from ACR or any OCI registry. Now, one of the things that I really like about the web apps is the webhook URL, which you see at the bottom, or the GitHub Actions at the top. And that allows us for continual deployment. So we can push an image to the ACR as part of a CI/CD process. And then that will, we can use that webhook to configure the web app here. And that means that when the new image is pushed, it will automatically pull down the image and deploy it to your app service plan. So you get continued CI/CD really quickly. Now, container apps. Container apps are a newer service on Azure, been around for a few years now, and they work in some ways similar to app service plans. We have a really simple UI, a limited number of options, but they're backed with Kubernetes. So rather than sort of retrofitting containers into an existing service, this is kind of like what you do if you started completely afresh with a brand new PaaS service and backed it with Kubernetes. The layout, you might be familiar from the previous slide. So in this case, instead of making app service plan, we're making it as your app container environment. And that is our compute. And then inside that, we can place one or more container apps, app jobs, or function apps. So a very similar set of concepts to the app service plans. It is worth noting terminology here in the container apps doesn't match the app service plans, and it doesn't match Kubernetes. We have a huge overlap in functionality, but all the terminology is pretty much unique to the Azure Container Apps. Now, when we add in any of our containers, we can specify how they communicate with each other. So by default, they're going to be private and they're not going to be able to talk to anything else. But we can change the ingress just to be able to talk to other containers in the environment, or we can actually make them public. Now, unlike Kubernetes, where that's quite a complicated process, where you have to configure in Helm charts all of your networking, it is just a few simple options here. So the main advantage is that we have a lot of things that we get in Kubernetes, but without the complexity. We also get things like free SSL certs. We can easily set up public and private containers, and we have a lot of support for a lot of cloud native technologies, things like Dapper, OTel, and various others. We also have an extensibility model, and we've got preview support for add-ons. We're going to get more and more things added to it. Once again, they do support GPUs, but there are some limits around that. We get attached storage, sidecars, init containers, scaling, and all of the things that you'd expect from a containerized environment. At the moment, these only run Linux containers. So if you need Windows containers, you need to look at one of the other options. So as I mentioned, the terminology is not quite aligned, but it is really quick to get up and running. Now, the use cases for this are when we have a lot of cloud native microservices all running in separate containers, where we want some of those to be private, some of them to be public. We want to independently scale each of them because, unlike an app service plan, each of the containers in our environment can be independently scaled to cope with the load. The pricing model is also a bit different than our app service plans. Rather than paying for a fixed set of compute, we are now paying for the number of CPU seconds and the number of memory in seconds as well. And this can work really well because as we scale up, we're just paying for what we use. So we're not paying for a large app service plan when we don't need it. We're just going to be paying for what we're actively using. So how do we go about creating one of these? Well, we have to create our app environment. Looks very similar to making an app service plan. And then we have to deploy the individual containers. And again, here we're specifying our image, the environment it's going to go into, and various bits and pieces. We specify our target ports and if what the ingress mode is going to be as well. I've been comparing app service plans to container apps a lot so far, and I just want to continue that on just a little bit before we move on to the next service. So in app service plans, we have things called deployment slots. You can add a second version of your code, and that can sit alongside the currently running version, and then we can swap it over so that we get a zero downtime, sort of a green-blue deploy. And in container apps, we have a very similar concept, but they're called app revisions. Both of them support routing traffic to a percentage of traffic, to one of the slots. We can also swap back to a previous version, and it's only going to swap in the version if the apps are healthy. However, deployment slots are updatable. You can keep using the same deployment slot over and over again with new versions of the code. When we look at container apps, they are immutable and versioned. So each time we create a new revision, that is unchangeable. We have deploy app slot settings. Equally, on the other side, we have revision and application scope changes. So we can have settings that only apply to that particular version. In app service plans, we either have 5 or 20 deployment slots, depending on the plan size. While under Azure Container App revisions, we have up to 100 inactive revisions. The other comparison I wanted to make was about scaling. So both of them have both automatic and manual scaling options, and it will automatically remove unhealthy applications out of the pool. However, when it comes to scaling, app service plans allow you to scale either automatically or based on standard Azure metrics. Azure Container Apps are based on CADA scaling, which comes from the world of Kubernetes. And that gives us, at the moment, over 50 different scalars to pick from. So we could look at statistics around, say, a Redis database or a service bus queue or various other things. It's really extensible, on top of standard HTTP and TCP metrics. On app service plans, we're scaling the whole app service plan, where we can actually scale out a number of replicas per version of each container under ACA. And as mentioned before, the app service plans, you're always charged, even if you scale or turn everything off. Where container apps, we're going to be, we have the option, if we want to scale to 0, making it really cost effective. Now I've got a few more just to finish up with. So container workloads on Azure Batch. This is an older service, and I just wanted to just briefly mention it. And what the purpose of this service is to be able to take a workload and split it across lots of different nodes. So if you take something like, say, rendering a movie, we can then split each of the frames up to render and then send them out to lots of different worker nodes. Now, behind the scenes, this is using standard virtual machines and VM scale sets. And what we have, we set up a pool, and then we can distribute our workload across different worker nodes. It's designed for an application custom written software application to do that, to split up the workload and distribute it. And as such, in the portal, you see very little around the container workloads on Azure Batch. It's all done through the REST APIs. Now, as one use case for this is splitting up the rendering of an animation, for example. So it does have good GPU support. It also is good for doing things like map reduce tasks, which are often backed by files. So it has really good file storage support. It actually has support for probably one of the widest range of types of files that we can attach. But the drawbacks, well, as I mentioned, it has limited support in the portal, and it's really designed to work with custom written applications. So it's not suited to every scenario. So in addition, other use cases might be HPC compute tasks, but pretty much everywhere where the workload can be split and distributed. The good thing is the pricing model is based on virtual machines, and being virtual machines, you can choose the right type of virtual machine that suits your needs. The actual batch service itself is free. Now, I mentioned quite a few times there about GPU support and splitting up video rendering. It is now recommended not to use this service and to use Kubernetes instead. But I wanted to mention it because it does still exist, and it is still there, even though I say most people are moving away from that. So let's have a quick look at Kubernetes. Kubernetes is a huge ecosystem kind of within the bigger Azure ecosystem. Now, I'm not going to be able to explain the whole of Kubernetes in the few minutes that we have left. But if you are interested in getting started in Kubernetes and understanding some more of the basics, the Cloud Native Computing Foundation has some great set of videos. I've highlighted these two. They might look quite strange to be recommending at this point, but it is a short cartoon that explains the very basics of Kubernetes, and it's a great way to either get started yourself or for other people that you might want to explain Kubernetes to. But with that in mind, I am going to talk about just some of the basic concepts so we can get an understanding of how it works. So in Azure, we set up an Azure Kubernetes service, and this is kind of an Azure flavored version of Kubernetes, where they do some of the things for you, but you are pretty much on your own for a lot of it. The compute element of it is all provided through node pools. So each node pool underneath is a VM scale set, and that is the compute. And onto that, we put various pods, which then hold your containers and potentially a container with a sidecar. So the compute is all managed by the node pool. Without that, you don't have anywhere to run your applications. We're going to configure it using something called Helm charts. And this is a standard way of managing a Kubernetes cluster, no matter where it's hosted. You get GPU support. You can have attached storage, sidecars, scaling, works on Windows and Linux containers as well. It's a really flexible system, and it is tightly linked back to the Azure infrastructure underneath. And that's really what Azure Kubernetes Service gives you. It's Kubernetes, but when you start provisioning things inside Kubernetes, like I need a new node pool, behind the scenes, Azure will actually be provisioning standard Azure infrastructure, such as a VM scale set. But there is a really steep learning curve. And with small clusters, we can actually find that the overhead of running a Kubernetes cluster is quite substantial. So if you've only got a single web app and you put it on a Kubernetes cluster, then there is a lot of compute needed in order to run the services just to keep the cluster running. And it probably isn't that suitable. You're also responsible for patching the nodes, the actual Kubernetes service itself, and various other bits, and designing all the networking, how those pods talk to each other, how the ingress and egress works, and all of the other configurations. You have to have quite a deep understanding in order to get it right. So when would we use this? Well, if we've got a large-scale microservice-based system, and we have potentially a dedicated infrastructure management team that can look after this cluster. I think a lot of the serverless and PaaS options, it is viable for developers developing the solution to also be in charge of looking after the infrastructure in some cases. But when it comes to Kubernetes, it's quite a lot of work involved. Yeah, so a dedicated infrastructure team is often needed. Also, another use case is where you have GPUs or custom networking or some special cases. So how much does it cost? Well, there is a free tier of the Kubernetes service itself, along with Automatic, which adds in some of the some extra management for you. So it's starting to take over some of the patching and various bits. We have a standard and premium SKUs as well. But that's just the service. You then also need to pay for the underlying infrastructure for things like VMs. So let's quickly look how we go and create one of these. So again, we can do this just through a simple command. We're creating at this point both the cluster and the node pool. So I'm just going to create a single node pool, just create it with one node. We can then see this inside the portal, and we can see there that it's created a node pool using standard DS2 v2 VMs. And we can manage a lot of it through here. Now, as I mentioned, behind the scenes, what it's done is created another resource group, and it's actually provisioned a lot of standard infrastructure. So it's created as a load balancer, it's created as a VM scale set, a network security group, and an IP address. We never want to actually modify these resources directly. We will modify the cluster through a Helm chart, and the Helm chart will update these. But I wanted to just kind of show you that this is what it's doing behind the scenes. We are managing the AKS cluster, and then behind the scenes, it's using standard Azure infrastructure. This is a Helm chart. So in order to get our code running on that cluster, we need to actually deploy a pod, which we're doing in the very first bit here, specifying our image and our container ports. And then we need to add in a load balancer inside the cluster, an internal load balancer that will allow traffic to be routed to that individual pod. Once we've written our Helm chart, we need to apply it. And we can do that using kubectl. So we can connect to the cluster, and then we can apply that YAML file. We can also use kubectl to get the status, and you can see there that I've got one pod running, and we can list all of the services and their IP addresses. Inside the portal, we can also see it running. And as I mentioned earlier, there is other things going on, other pods that are running just to keep the whole AKS cluster running. And you can see them there as well. Now, before we move off Kubernetes, I wanted to explain that it's often part of a bigger picture. Kubernetes AKS does work with managed identities, so that'll be reaching out to things like Active Directory. We're pulling images from an Azure Container Registry and ACR. A load balancer sits in front of it, and often we don't want to put persistent data into a Kubernetes service. So things like databases or table storage and key vaults would sit outside. So even though we have our Azure Kubernetes service, it works really well with all of the other infrastructure that we have and is part of a bigger picture. The final thing I wanted to mention is Azure Virtual Machines, and there is still a place for them. And it gives us full control over everything. So it does mean if we wanted to use a different orchestration rather than Kubernetes, we could use something like Docker Swarm. We can still do that with virtual machines, but everything is in your control then. So you have to be responsible for patching, designing, networking, and literally everything. So there's only a few scenarios where you'd want to do this. It'd be custom scenarios, or if you're potentially doing a migration from an on-prem system, you might temporarily use a virtual machine. And as we probably know, virtual machines are charged by the size of the virtual machine per minute. So that's a really quick kind of whistle-stop tour through all of the different offerings, from the container instances, the specialist container supports. We looked at app service plans, the newer Azure Container Apps, which sits nicely in between app services and Kubernetes. We looked at the older workloads on Azure Batch, and also finally just talked about containers on virtual machines. I realize that was quite fast, and no doubt there'll be a few questions which we can take in a few minutes. But for this talk, I have put some notes together, some links off to some Azure resources. So you can find them on that link, and we'll put that in the chat as well. And you can also find me on the socials, as I said. If you want to reach out to me afterwards, you can do that at John Kilmister. So I'll pass you back to our hosts. Thank you.
Yes, thank you so much, John, for the great presentation. That's very informative and a lot of things that we learned today from you. Thank you so much. Even if I've worked a lot with Azure, I've learned that I like your presentation in a way that you presented the pros and cons and the different perspective of all container hosting. That's great. Let's see if we got questions from others. Oh, we did not get a question. I mean live right now, but we did have a question about like if they could get a copy of the slide later on. I think you will share it also, John, right? I think this is
Yes, I can do that. Yes, that's
yeah.
not a problem.
Yes, that would be great. We'll share it.
Yeah, what I'll do is I'll put the slides on that link. They're not there at the moment, but I'll add that later.
All right, that's great.
I have a question here for you, John. So, as a first of all, thank you for a very good overview of these different types of services. But I'm wondering, I understand here that for the last option, Azure Kubernetes services, then you should probably know quite a lot about lot of Kubernetes. But what about the other options? Is Kubernetes totally abstracted away from the developer, or should we still learn some Kubernetes anyway? What is your thoughts on that?
Yeah, so when it comes to Azure Container Apps, which are backed by Kubernetes underneath, no, I wouldn't say you necessarily need to know Kubernetes in any particular depth. As I said, the terminology is quite different. So we're not talking about pods, for example. We talk about apps. So no, you don't really need to know. Don't need to know. What can be useful though are things like understanding the health endpoints that you might want to expose on your Docker container, because both Kubernetes and Azure Container Apps both support the same concepts when it comes to health endpoints. Also, Azure Container Apps supports the CADA scaling. Now, CADA is one of many options when it comes to scaling inside Kubernetes, but knowing a little bit about how that works might help. But no, I don't think you need to know as much as you would if you were running a full Kubernetes cluster.
Yes, that's good. I also have a question because containers is also one of the things that I'm interested to kind of like learn more. And I know that when I spoke at Microsoft Ignite in a theater session, one of the topics that got accepted was the topic of me sharing Azure functions in a container apps, which is also pretty good. But if I was a beginner and I'm new to containers, you wonder. I mean, first of all, I will watch the session that you just delivered today because I really like it that you kind of like segmented all the features, the pros and cons, the good and the bads of it. But in your perspective, as someone that worked with this technology or shared knowledge about it, what is what is your advice to those that are new in container development and how they should like tackle challenges that are so common? Like first challenge I know is choosing the right container hosting option, and then other challenges that you might know that maybe it's good for our audience to be aware of as a beginner, for example.
Yeah, so a couple of different things. When it comes to building your containers, you need to think about what's going to go into that container. So you can do things like multi-container build. So if you want to build your application inside the container as part of the container, we don't have to have so I'm trying to think of a way of rephrasing it. So with a container, you have a base based image, which specifies kind of the operating system you're going to be running on. You want to keep that as light as possible. So if you're in the world of .NET, for example, there are chiseled images, which are a lot smaller and easier to use. What you don't want to do is, for example, put your full SDK that has the ability to build your application as your base image. So you can either build your application outside of the container and then copy the files in, or you can do a multi-stage build where you have inside your Docker file that you're building your image. It will use a base image that has the SDK in. Then it will copy it to a lighter image, a chiseled image, for example, which then gets published. So the final thing that gets published is a lighter weight image. So yeah, that's one thing to be aware of. The other I would say is that although Windows containers are supported, if you can run them under Linux, the containerization is really kind of focused on the Linux community. Windows is supported, but it's a challenge to run sometimes. So yeah, I would always kind of stick with Linux if you can. And that doesn't mean you have to develop on Linux. You can still develop on Windows and then deploy to Linux. But yeah, if you're starting afresh, build with a Linux container. Yeah, they're kind of my tips around that
How
area.
about I have one thought in my mind. How about versioning? What's your perspective on versioning? Because I know versioning is one of the things you also have to do or work with when you're developing with containers.
Yeah, so there's a really good blog post, and I think I linked to it in there about tagging your tagging your images. So you can tag an image with multiple tags, and one of the strategies that I read about and I do actually use is to tag your image with V1, V1.1, V1.1.1. So you tag them with the major, minor, and patch, and then that allows you to when you produce the next version and you tag the image again with the same numbers, it will then adopt that one. So you'll be left with your older version so if you wanted a particular version, it's still there tagged. But if you said, I just want version 1, it will get the latest of version 1. I might be explaining it poorly. There's a great link and a great animation in the notes.
Yeah, that's great. You're doing great. I like it. I like the strategy also. It looks like how we use the versioning when you're doing deployments on DevOps on the CI/CD pipeline.
Semantic versioning with
yes, that's right.
But doing that through tagging your containers, and it allows the consumers of those containers then to pick either just the latest major version, the latest minor version, or a particular patch version. They have that flexibility. So yeah, you can get that. But I've done a poor job of explaining it. But in the links, there's a really good video, a really good animation that shows it.
Yes, I want us two more questions. So we're also out of time. We're over time now, but we do have our what do you call Zoom meeting. This is the voluntary after session fika for more questions after the live stream. So join us on that bit.ly link as Azure Sweden fika 2025 if you want to join us. John will join us. I will be there. Yes.
Because I have a comment here from our audience from Taco Susuyama, who says summary chart is very useful. I will refer to it many times. So thank you. Thank you so much for that.
I really like how you did the chart, John. I would like a copy of your presentation too. Yes, another one. I know him. Simply is the nickname. Yes, I know.
So maybe you can take it, Jonah.
Yes, simply. Yeah, we got a feedback. I know him. He's from Sundsvall, so it's also nice because you can deploy the exact same artifact to multiple environments just give the image multiple tags. Yes, the versioning. Yes, that's great. Okay. I don't think we have more questions, but before we end our live stream, I just want to thank you, John, for your time with us. I always value the time we spent in our user group, especially that we have it every weekend. So I do appreciate, instead of eating lunch, you're sharing out knowledge with us. So thank you so much. I do appreciate it. How about you, Håkan? Any words?
Yeah, I just want to thank you so much once again. I think this is a session that people will want to review again.
Yes.
There's a very
Yeah.
valuable information.
Well,
Yes,
thanks for
I
having
just
me.
yes, I did actually send out a message to all members of the user group to check out the YouTube link. Even if they may still live, they can watch the recorded version. Okay, it's time
Thank
to
you.
say goodbye again, Håkan. Any last words? By the way, I mean last words for this session, John. Like upcoming events, upcoming engagement to the community that you want to share. Any initiatives that you have that you want to share?
Nothing particular at the moment. I've got my
Hmm.
monthly blog post, which
Yeah.
I think next month I'm going to be talking about uh, a little bit about patching our containers and our base images. And then the month after, I'm going to be talking a little bit about moving from Windows to Linux app service plans. So yeah, I've got those
Okay.
blog posts coming up.
It's great.
Other than that, no.
Yes. Is your link to your blog post shared right on the links
Yeah,
that you
that's in
sent?
that same link.
Okay. All right. That's great. And okay, time to say goodbye and hope to see you on the Zoom meeting. Otherwise, see you again in the next stream in 2 weeks. We have something scheduled as well. So sign up for it in our meetup group. But thank you so much and have a great weekend, everybody. Have a great weekend, John and Håkan. Bye.
Bye.